Okay, this is the last section in the polynomial chapter, and this is called the rational zero theorem. And it follows from what we did last time, in that last time was part one, where we found what was possible. What were the possible number of positive real zeros on the right side, or yeah, whatever. On the positives, we found positive zeros, negative zeros, and imaginary zeros, which are out there somewhere. They really are. We just didn't graph them. Anyway, we used to find zeros of quadratic functions. Now we're going to find the zeros, the possible rational zeros, and all of the actual zeros, rational ones, of a polynomial function. And it's a two-part adventure. And I wanted you to see this first. I circled it because I thought it was really, really important. In that, if you were to translate this into colloquial English, here's a polynomial, here's some polynomial function, and this just means its coefficients are integers. That means the numbers in front of the fractions and the constant term are not fractions. I don't think I said that right. It doesn't matter. Just no fractions, no decimals, okay? And what that says is that every time you get a zero of this polynomial, it's going to be in fractional form, which is kind of a cheap way of saying that, yeah, everything's a fraction because 3/1 is a fraction. So yeah, the zeros are all fractions. And they're telling you that in this fraction, the numerator is going to be a factor of the constant term, which is the last number, and the denominator is going to be a factor of the lead coefficient, which is the first term. And that's what all that says, and there's a reason for it. And here it goes. What they told us, if you were looking, is that 4/3 is a zero of this polynomial, which means I could write x equals 4/3 when y equals 0, which means I could multiply both sides by 3 and say that 3x equals 4, which means I could also subtract 4 from both sides and say 3x minus 4 equals 0, or that 3x minus 4 is a factor of said polynomial. Now, theoretically, let's just say I had some other random factor, and if I FOILed this out, that would, well, obviously it wouldn't work because this is a quartic, but let's just pretend. Bear with me for a minute, okay? What I'm trying to say is that if I did all kinds of fancy multiplication, the first two numbers are going to give me that, and that 3 came from the denominator. And my last two numbers are going to give me my constant term, and that 4 came from my numerator. So that's where all that comes from. What you need to remember is that P, the top of the fraction, is a factor of the constant term, and that Q, the bottom of the fraction, is a factor of the lead coefficient, blah, blah. Now you're going to list all the rational zeros. So we're going to list all the P's, all the possible P's, which in this case, all the factors of 4 are 1, 2, and 4, 1 times 4 and 2 times 2. And you're going to list all the factors of 3, which I have done so here. So what are the possible factors of P? And did I mention they're all positive or negative? Because a negative times a negative is a positive. And any combination of the above. So all the possible factors of P are those. All the possible factors of Q are those. And if I'm writing my fraction P over Q here, I have to write every possible permutation of those. So I would say 1/1, 2/1, 4/1, 1/3, 2/3. Oh dear. I was not going in order there. I totally lost my mind, and there's only 6. Let's try it anyway. All right, so we've got, anyway, I wrote them all out here. Here you go. So what are all my possible P's over Q's? I've got 1/1 and 1/3, 2/1 and 2/3, 4/1 and 4/3, and that is everything. There's 6 of them. And I know that because the fundamental counting principle says that if I have 3 of one option and 2 of another, I'm going to have 6, 3 times 2 possibilities. There they are. That's the first question. That's the first question you'll have to answer. So let's do it a couple more times to make sure it makes sense to you. All the p's are the factors of that, and in this case, all the q's are 1, which is a beautiful thing, because all you have to do is list the factors of 15. And remember to use the positive and negatives. You got 1 and 15 and 3 and 5, and that is all of them, and all the positives and all the negatives, and that's done. So whenever you see one of these, pause the video and get your own solution and then come back and see if you're right. So pause. And you're back. And hopefully you got C. And as always, if any of these don't make sense, send me an email. I'll send you a solution. And you're going to do it again? That meant pause. And I hope you're back. And the reason there's so many, well, all right, it's not C. There's a lot of numbers, frankly, it's A or B, because 24 is one of those friendly numbers. It has a lot of factors. And all you had to remember was that the P's go on top, the factors of 24 go on the top, and Q's go on the bottom, and you should have been able to figure out it was B. And all the factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. Dang. And when you get to the middle, you stop, because it'd be silly saying 6 and 4 because you already did it. So now we're actually going to find the zeros. That was all the possible zeros. Now we're going to find out which ones actually work. And it's not as bad as it could be, but we're going to start off using the fundamental theorem of algebra. How many zeros does this polynomial have? It has 4 complex roots. Why do we say complex? Because all roots are complex, period. It's got 4 roots. We need to know that. Then you'll need to know how many, of which kind, how many and what kind of roots are there. So you'll count your positive roots with f of x and your negative roots with f of negative x. And we are experts at that now. So the positive is easy. We've got 1, 2 changes. So we've got 2 or 0. We've got 2 or 0. Using Descartes' rule of signs, there are 2 or 0 positives. And if we had indeed done the negative thing, this would be positive, this would be negative, etc., we would have got 2 or 0 negative real roots. So we'd have to figure out what they are now. Then you would find step 3 is what are the possible rational zeros. And since this is 1, it would just be all the factors of 30, positives and negatives. So we would write those all out, 1 and 30, 2 and 15, 3 and 10, 5 and 6. And we would write them all out, positives and negatives. Now, here's where it could get really ugly, but doesn't, because theoretically, you'd have to check every one of those to see if they work. Fortunately, we have calculators and we can plug numbers in. So we're just going to check them one at a time. You're going to have to try positive 1, negative 1, positive 2, negative 2. But the kind of problems you're going to get are mostly going to solve out before you get to too many. So there. So here they are, all my possible rational zeros, and I'm going to try positive 1 first. So I'll try positive 1 by plugging it into here. 1 to the 4th plus 1 cubed minus 19 times 1 squared plus 11 times 1 plus 30. It does not equal 0. I do not have the foggiest idea what it equals, but it does not equal 0, so it is not a root. I don't care. So the next thing you could try is negative 1. Negative 1. Didn't work. But positive 2 does. When you plug 2 into here, you get 0, so we have our first 0. Yay. So that is my first 0. So now, what I'm going to do is use synthetic division to see what's left when I pull the 2 out of there. So I will find the depressed polynomial. So using synthetic division, I will put down 1, 1, 1, 1, negative 19, positive 11, 30. And then I am, of course, dividing by 2. So I drop the 1. 2 times 1 is 2. And 1 plus 2 is 3. 2 times 3. I have a stray negative that does not belong there. It's positive 6, negative 13, negative 26. Add those two, get negative 15. 2 times negative 15 is negative 30. And it's a beautiful thing because I got that 0 remainder, which means I am doing the right thing. And then it was a 4th, so now these are cubed. This starts off with a cubed. plus 3x squared, because I divided by x, minus 13x minus 15. And that is my depressed polynomial. And if I actually multiplied it out, I would have x minus 2. Remember the opposite sign from the 0 times this would give me my original polynomial. So that's the first step. Unfortunately, I have to do it again because looking at this, it's not a clean factor. I can't, if I tried to group that, yeah, I could pull an x out of these two, but I've got a negative 13 and a negative 15 and they don't help me. So there's my depressed polynomial. I was going to let you see it all nice. There's my depressed polynomial. And I'm going to need a pen back. And now I got to do it again. Now, I already know that 2 is one of my positive real zeros. So there can't be just one of them. There's either, there can't be 0 because there is one of them, so there has to be 2. So there has to be one more positive. So then I'll keep, I didn't have to try -1 before because I'm looking for positive zeros. So I tried +1, I tried +2, now I'll try +3. And wonder of wonder, miracle of miracles, when I plug +3 in there, using my calculator in that snazzy way we did it in the warm-up, I will also get 0. I will once again find my depressed polynomial using synthetic division. You guys should be good at synthetic division at this point, so that shouldn't be a problem. And dividing by 3, I should get, and this time it's a squared because it was a cubed. So it's x squared plus 6x plus 5, which is a beautiful thing because I know that's factorable. So now I've got this times x minus 3, opposite sign from the positive 3 times x minus 2. And I've got my 2 positive solutions, and I should get 2 more negative solutions. I'm not even going to erase that. And you're going to factor that, which you should easily be able to do, knowing that it's 6 and 5's always mess me up. It's either 2 and 3 or 5 and 1, but in this case, they're both positive, so it's the 5 and 1. So I'll write the depressed polynomial. I'll factor the depressed polynomial. I will solve for the direct blah, blah, and I will get 2 negative solutions. So that's what I knew I had. 2 real negative solutions and 2 real positive solutions. So those are the zeros of my function, and that is the end of that problem. There's only one more thing you have to do. Okay, there's one more example here, and you should, actually, there's a couple of real life problems, but we're not going to do those today. So we're going to stop after this. So you got to try to do this by yourself, and if you you should pause, see if you can get the answer, and then come back. And I assume you're back, and hopefully you got D. And if you did, you're done. You can go do the practice. If you want to see how to get D, then just keep listening, and I'll do it real quick. We've got, using the fundamental theorem of algebra, we've got 4 zeros. What kind of zeros are they? Well, we'll do f of x. This is a positive. We've got no sign change, 1 sign change. We've got 2 sign changes, so we've got 2 or 0 positive real zeros. And then we'll do f of negative x. And this one's going to be positive because negative to an even power is positive. And here we have a negative to an odd power, so that's negative, and a negative times positive is a negative. And here this one's positive, and negative squared is positive, but then that's a negative, so there's a negative. And here we've got a negative, negative. That's a positive, and here we have a positive. So we have 1, 2 sign changes, so I have negative real zeros are also 2 or 0. That's the number of them. Now I have to find out what they are. Now I'm going to find out what they could be, all the possibilities. So fortunately for us, the lead coefficient is 1. I just need to factor my constant term, and all the factors of 45 are 1 and 45. 2 doesn't work, 3 and 15. 4 doesn't work, but 5 does, 5 and 9. 6, 7, 8. Okay, so that's it. So that's all my possibilities. Now, I do need to know that those are all positive and negative. And technically, I should try them all, but we know there's 2 or 0 positives, so let's try positive 1, then positive 3 first, right? So f of 1, if I plug that in, if you forget how to do it, look at the warm-up for today. But I'm going to plug that in and find out by some miracle, yay, it is a 0. So now I will use 1 in my synthetic division. And I'll put all of these in there. So I've got 1 and 4 and negative 14 and negative 36 and positive 45. And I'll drop the 1. And 1 is 1, and I'll get a 5, and 1 times 5 is 5, and I'll get a negative 9, and I'll get a negative 9, and I'll get a negative 45, which is a beautiful thing, because the negative 45 times 1 will drop out and give me the 0. So there's my depressed polynomial, which is going to be, since this was to the 4th power and I divided by an x, it's going to be x cubed plus 5x squared minus 9x minus 45. And again, actually, I could factor this one by grouping, couldn't I? I think I can. I wasn't planning to do that. I was going to do... Shoot. I'm going to finish it, and then I'll check at the other. I think I can group that. But, because I take a negative 9, that works. All right, so anyway, but you finishing it this way. And isn't it nice to know you have options? I'm going to try positive 3. And I'm going to plug it into my graphing calculator. And by some miracle, 3 is also a 0. Yay! So now I will use synthetic with the 3. I'll put the 3 in a little box, and I'll see what I got left. I got a 1, I got a 5, I got a negative 9, and I got a negative 45. Drop the 1. And I'm going to have 1 times 3 is 3. I have an 8. 3 times 8 is 24. Minus 9 is 15. And 3 times 15 is positive 45, which is exactly what I wanted it to be. So now my depressed polynomial is going to be x squared, because it used to be a cubic, plus 8x plus 15. And that factors into x plus 5 times x plus 3. So I do have 2 negative real roots to go with my 2 positive real roots. My 2 positive real roots are 1 and 3, and my 2 negative real roots are negative 3 and negative 5. So well, I hope you can do that. And if you can't, well, don't worry. I will provide multiple opportunities for you to practice before you have to do it on a test. Now, you can stop watching right now, or you can watch me see possibly crash and burn here. We've got, I'm going to factor out an x squared. Oh, yeah, this is going to work. So I don't care how you do it. Just get it right. So if I factor, I'm factoring this bad boy. So if I factor an x squared out of there, I think it's going to work. I'm going to have x plus 5. And if I factor a negative 9 out of there, I'm going to have x plus 5, which is exactly what I want. Yeah, okay, I lost it for a moment. I already know that 1 is one of my factors. And this will give me x squared plus 9 minus 9 times x plus 5. And that will give me the negative 5 and the positive and negative 3. So there you go. You can do it either way. Have a nice day. Don't forget to practice and all that good jazz.